Alright, I'm just going to do one more example here of graphing quadratics in vertex form. One last time. Vertex form is y equals a times x minus h squared plus k. And if you recall, your vertex will always occur at the opposite of the h and the same as the k value. We'll also use a as our stretch or the compress of the function. Remember, a will stretch the graph if it's bigger than 1, and it will compress the graph if it's less than 1. Alright, so let's look at our example here. I'm given the function f of x equals 1/2 times x plus 2 squared. So if I want to find my vertex, I want to find the opposite of h the same as k. Well, in this case, you'll notice that I have an a and h, but there's no k over here. That's really the same thing as having a plus 0 on the end. So my k value is really just 0 in this case. So my vertex is going to be at the opposite of the h, -2, the same as the k, 0. So I can go over 2 and up 0. That would be the vertex of the equation. Now, once I find the vertex, I then use my a to find the next 2 points. Okay, so right now my a is 1/2, and we always put the a over 1 to find the next 2 points. So I want to put 1/2 over 1. Now, remember that the top is the rise, the bottom is the run of how much it's being stretched. So this time when I go over 1, I should go up 1/2. And when I go over 1 the other way, I should go up 1/2. Notice that this will end up widening the graph, and that's because 1/2 as a transformation compresses my graph. And it compresses it in the vertical sense. It's squishing it down, which ends up widening it out. Now lastly, I need 5 points to be able to graph this function. So I'm going to plug in an x value I haven't used yet. That's nearby, and that one would be 0. So if I plug 0 into the function, so I'm plugging in 0, I'm going to get 1/2 times 0 plus 2 squared. Well, 0 plus 2 squared is really just 4, and then 4 times 1/2 is going to leave me with 2. So when I plug in 0 into the function, I get a 2 out. So at 0, I should be up 2. And then to find my fifth and final point, it's important to remember that quadratics and parabolas are always symmetrical. So if I go over 1 and up, I should be at 2 as well. And the graph will look like that.